Hello students, welcome to LearnGuru Classes. So today's class is the continuation of the last class. So last class we have studied in detail about decimal expansion of a rational number, where we have studied what is a decimal number, what are the types of decimal expansion like terminating decimal expansion and non-terminating decimal expansion, and after that we have taken some rational numbers and we have identified the type of decimal expansion by performing long division. So today we are going to determine the terminating and non-terminating decimal expansion without performing long division method. So there is a certain rule of identifying the type of decimal expansion. So let's look into it. So let us start our class. So first of all, what is the condition for terminating decimal expansion? Terminating decimal expansion, how we are going to check? Expansion is the denominator of the rational number should be either of three types. So what are these three types? It may exist in the form of 2 to the power m into 5 to the power n. Second is either 2 to the power m or 3 is 5 to the power n. Okay, now what is it? So let me make it clear to you. Okay, so how do we obtain a decimal expansion? With the help of a rational number, isn't it? Suppose a rational number in the form of p by q is given to you, where q is not equal to 0. Okay, so once it is done, next is you are going to see q is the denominator, right? Q is the denominator, p is the numerator. Now the value of q should exist in the form of either 2 to the power of m into 5 to the power of n, or 2 to the power of m or 5 to the power of n. Okay, so for that let us take one example of 7 by 8. Let us take the example as 7 by 8. Okay, 7 by 8. Okay, so the condition I am writing here once again, 2 to the power of 5 into 5 to the power n. Second is 2 to the power of m. Third is 5 to the power of n. Now I have taken an example of 7 by 8. So to identify or to determine whether the denominator is of the form of 2 to the power of m of these types, what we do? We go for factorization. What do we go for? We go for factorization of the denominator. So factorization. How do we do factorization? Factorization is, suppose 8. So 2 4s are 8. 2 2s are 4. So factors of 8 are what? 2 into 2 into 2, isn't it? Now 2 is repeated 3 times. So we can just replace it with 2 to the power of 3. We can replace it with 2 to the power of 3. Okay, so 2 to the power of 3 means what? 2, and within it there is one power, that is 3. So can you say this is the replica of 2 to the power of m? This symbolizes 2 to the power of m. Yes, so we can say that 7 by 8 is a terminating decimal expansion. Terminating decimal expansion. Okay. Do you want to check whether whatever I am telling it is correct or not? Okay, let us perform cross check it with the help of the long division method. See, 7 by 8, I am just cross checking it. 7 by 8, I will perform the division. So to perform division, we are dividing the numerator by the denominator. So 7 by 8, 7. So 7 is less than 8. So you have to put a 0 and a decimal. 8 8 just 64. Here is 6. Again 6 is less than 8. So again you are giving a 0. 8 7s are 56. Again you are having remainder as 4. Then you are giving a 0. 8 5s are 40. So you are seeing that the remainder is coming to be 0, which is a terminating decimal expansion, because we already know that in a terminating decimal expansion there are finite numbers of decimal the finite number of digits after the decimal point, and the remainder comes to be 0. So here remainder comes to be 0. So we can say that 7 by 8 is a terminating decimal expansion. Okay, or from 7 by 8 we are getting a terminating decimal expansion. So this is just a cross verification of this method or this condition. Okay, I think it is clear to you. Again, let me take another example. Let me take the example of 3 by 40. So, which one is the numerator? Which one is the denominator? 3 is the numerator and your 40 is the denominator. Now to check terminating decimal expansion, what you have to do? You have to factorize 40. You have to factorize the denominator 40. Okay, and so let us factorize 40. So 2 2s are 4, 20, 2, 10, 2, 5, isn't it? So factors of 40 are, factors of 40, what are the factors of 40? 2 into 2 into 2 into 5, isn't it? So 2 is repeated 3 times, so we can put it 2 to the power of 3. 5 is repeated only once, so 5 to the power of n. So is it following, or does it resemble this expression 2 to the power of m into 5 to the power of n? Yes, it resembles this expression. So from that we can say that it is also a terminating decimal expansion. Okay, so this is a terminating decimal expansion. Terminating decimal expansion. Okay, so this is how we judge whether it is a terminating or non-terminating decimal expansion. Okay, so let me take one example, that is another example. Let me take 5 by 24. 5 by 24. Now you tell me whether it is a terminating or non-terminating decimal expansion. So for that what you have to do? You have to factorize the denominator. So 24, 2, 12, 2, 6 are 12, 2, 3 are 6. So what are the factors of 24? Factors of 24 are 2 into 2 into 2 into 3. So 2 is repeated 3 times into 3 to the power of n. So is it resembling any of the 3 methods? No. 2 to the power of n we are getting, but with that it should come as 5 to the power of n, but you are getting here 3 to the power of something. Okay, so from that you can say that it is a non-terminating decimal expansion. So therefore this is a This is a non-terminating decimal expansion. Okay, so I think I have taken only 2 to 3 examples, so to show you which one is terminating and non-terminating decimal expansion. So let us look into more examples so that the concepts of this method is crystal clear to you. Here I have taken 3 examples to determine whether these 3 are terminating or non-terminating by the method I have shown you. So what is the condition for a decimal expansion to be terminating? You already know by now. It should be, I am writing over here, okay, in one corner. It should be either 2 to the power of, or I will write here so that it will be more prominent. One condition is 2 to the power of m into 5 to the power of n. Second is 2 to the power of m. Third is 5 to the power of n. It may be, if it is either of the 3, then we can say that it is a terminating decimal expansion. So let's check one by one. So first is 7 by 80. So what is the denominator? 80 is the denominator. So you have to perform factorization first. 280, 40, 220, 210, 5. So factors of 80 are what? 2 to the power 2 into, I am just rubbing it, 2 into 2 into 2 into 2 into 5. So 2 is repeated 4 times. So we can say that it is 2 to the power of 4. 5 is repeated only once. So it is 5 to the power of 1. So is it of the form 2 to the power of m into 5 to the power of n? Yes, it is of the form of 2 to the power of m into 5 to the power of n. So we can say that it is a terminating decimal expansion. So therefore it is a terminating decimal expansion. Okay, next is 5 by 28. So same here, you have to factorize the denominator. So how will you factorize? 28, 2 ones are 2, 2 fours are 8, 2, 7. So factors of 28 are, factors of 28 equal to 2 into 2 into 7, that is 2 square into 7. So is it following under any of this category? 2 to the power of m we are getting, but along with this you are accompanied by another one, that is 7 to the power of n, or into 7. So it is not falling under this category. So from that we can say it is a non-terminating decimal expansion. See how easy it is. Without doing long division method, it will save your time. Okay, until and unless if it is asked in the exam to perform long division method and say terminating or non-terminating, that time you are bound to do so. But here only from that we can say that it is a terminating decimal expansion. So let's move on to the next sum. So that is 6 by 75. What is the factors of 75? Factors of 75. So we have to perform the factorization. I am performing the factorization here. So it is divisible by 5, 75, 15. Okay, 5 3s are 15. So here we will write factors at 5 into 5 into 3. So it is having 5 square into 3. So again I am writing the condition, I have rubbed it. So these are the conditions for terminating decimal expansion. So is it resembling? Is it resembling? Yes, it is not resembling anything. So from that you can say that it is a non-terminating decimal expansion. But here there is a twist. Okay, so before telling you the twist, let us cross verify it with long division method. Okay, so let me cross verify it. So 6 by 75, 6 by 75, so 6 0. So 660 is first of all 1 point, then it is less, so again 1 point. So 75 into 8, 8 8 5s are 40, 8 7s are 56, 57, 58, 59, 60. So you are getting 0.08. So you see remainder is coming to be 0. Isn't it? Remainder is coming to be 0, and so we can say it is a non-terminating decimal, terminating decimal expansion since remainder is 0. But here it is showing that 5 square into 3 means it is not of any of these forms. Okay, so it is violating the rule, right? Long division method is violating the rule of this method. Okay, so how is it? So here you have to apply your brain. Okay, see here. 6 by 75, isn't it? Here you have to see the common factors in both the numerator as well as the denominator. 6, how can we write? If we break 6, we can write 3 into 2. 75 is 5 into 5 into 3. So can I cancel 3 and 3? So it is of the form 2 into 5 square. Yes, 2 by 5 square you are getting. So is it resembling of the form 5 to the power of n? Is it of the form 5 to the power of n? Yes, it is of the form of 5 to the power n. So from that what can you say? That this is a terminating decimal expansion. Okay, so you have to keep in mind about the common factors in both the numerator and the denominator. So this also plays a vital role. You have to keep in mind about the common factors in denominator and numerator. So if you find common factors in the numerator and denominator, then obviously you have to cancel those common factors. Okay, so this is a twist. Okay, so this is an exception or anything you can say, so little bit tricky. Okay, so for determining terminating decimal expansion, what you have to do? Factorize. First steps involved are What are the steps involved for determining terminating decimal expansion? Terminating decimal expansion. Let's see. Okay, so what are the steps involved for determining terminating decimal expansion? So the first is you have to factorize the denominator. Factorize the value or factorize the denominator. In simple language I am writing. Okay, factorize the denominator. Second is you have to write the factors of the denominator. Third step is check whether the factors are of the form 2 to the power of m, are either of the form, okay, are either of the form 2 to the power of m into 5 to the power of n. Second is 2 to the power of m. Third is 5 to the power of n. And fourth is check common factors in both numerator and denominator. So all the 4 points you have to keep in mind. First of all, factorize the denominator. Take the, suppose 3 by 80, you do factorization, keep it as a rough work, okay. So in the main part, right, factors of 80 are, so 2 into 2 into 2 into 2 into 5, so 2 is repeated 4 times, so 2 to the power of 4 into 5. I am just taking an example. So after that you will see, check whether the factors are of either of the form, any one of the form this. So again after that you have to see, check common factors in both the numerator and the denominator. Like I have given you the example of 6 by 75, where there are common factor, we have common factor is 3. So once we cancel 3, then the denominator comes of the form of 6 by means by 25, like 6 by 75. So here 6 by 75 can be written as 5 square into 3, and 6 is 3 into 2, so 3 got cancelled, so 2 by 25. So it is of the form of 2 by 5 square, isn't it? So we can say that it is a terminating decimal expansion. So all the 3 factors you have to keep in mind whenever you see any rational number and you are asked to determine whether it is a terminating decimal expansion or a non-terminating decimal expansion. Okay, so this is the end of today's class. Next class we will see how a decimal expansion can be converted into a rational number. Okay, so I am ending the class here. So if you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you so much. Bye bye.